Hello friends, welcome to my channel Master the Monster. Let's enter into the world of polynomials. Trust me, this is going to be an easy and interesting section of mathematics. You may have few doubts and questions regarding polynomials, the degree of polynomials, zeros, division of polynomials, what are quadratic polynomials, geometric meaning, all those things in your mind. No worries, let us sort out all the questions one by one. Before that, subscribe to my channel so that you will enjoy learning maths. Class 10 CBSE Maths Chapter 2 Polynomials Exercise 2.1 Problem number 1. The graphs of y equal p of x are given below for some polynomials p of x. Find the number of zeros of p of x in each case. So the problem given here is you are given graphs. Okay, and each graph represents a polynomial. What we have to do is we have to find the number of zeros of each of this polynomial, right? Okay, now we have seen the geometric meaning of zeros of a polynomial in our previous video, right? I have given the link in the description box. You can look at it before you do this problem, right? So that you can understand better. Okay. Now in that video, we have seen that the zeros are nothing but the zeros of polynomials are points of intersection or points where the polynomial, the graph, points of intersection of the graph with x-axis. So zeros represent the point of intersection of the graph with x-axis. This is the geometric meaning of zeros of polynomials we have seen. So from this we see that the number of zeros of a polynomial will be equal to the number of points where the graph cuts x-axis. So the geometric meaning of zeros is the points where the graph cuts x-axis. So number of zeros will be number of points where the graph cuts x-axis, right? This is what we are going to use in each case and find out how many zeros on each polynomial has, okay? Okay, now consider the first case. Here, the graph is very well a straight line. And does it cut the x-axis? No. It cuts only the y-axis. But our geometric meaning is that it should cut the x-axis. So, here the graph does not cut the x-axis. So, the polynomial has no zeros. Because the graph does not cut the x-axis. Okay. Okay. Now consider the second subdivision. Second subdivision is a curve and does it cut the x-axis? Yes, it does at one point. See, this point is the intersection of the graph and the x-axis. So at how many points it cuts the x-axis? It cuts the x-axis at one point. So I say this polynomial has 1, 0 because it cuts x-axis. The graph cuts x-axis at one point. Right? Therefore, this polynomial has 1, 0. Okay, now come to the next graph. That is my third graph. See, it cuts x-axis at how many points? See, this is my first point. This is the second point. And this is the third point. So, the graph cuts x-axis at 3 points. Therefore, the polynomial has 3 zeros. I will proceed to fourth subdivision. See here, the graph cuts x-axis at 2 points. Therefore, I say the polynomial has 2 zeros. Okay, here again, fifth subdivision. The graph cuts x-axis at 1, 2, 3 and 4. So at 4 points, therefore, the polynomial has 4 zeros. And the next case, the final graph, it cuts the x-axis at 1, 2, 3, so it has 3 zeros, right? Do you understand? This is how we find the number of zeros of polynomials given its graph, right?